Another example of pollutants that enter into the marine ecosystem are toxic chemicals. And these quite often consist of what we know as persistent organic pollutants, or POPs. These are really harmful organic compounds. And one of the reasons why they're harmful is they're extremely stable and they have low biodegradability. So they stick around for a long time. There are a number of sources of these POPs, these POPs. They come from pesticides, they come from drugs, they're introduced through industrial chemicals and solvents. They enter into the ocean and they are incorporated into the marine organisms. There's a list of some here, things like benzene, chloroform, dioxin, PCBs. Some of them are no longer used. For example, the effects of humans can be really, really great. And we can see some of the major health effects listed there. These aren't health effects on fish. These are health effects on humans. And you can just imagine what this can do to a fish that eats or ingests these types of chemicals, these types of organic compounds. For example, PCBs, polychlorinated biphenyls, they can cause liver, kidney, and lung damage. So they have potential adverse effects on human health and on the environment. One of the things they're used for is in dry clean fluids. We've seen in the past that sometimes dry cleaners would put their solvents they used down into the sewer. Once again, then, this is an excellent pathway by which these persistent chemicals, these persistent toxic chemicals, can enter into the ocean system. Another thing that makes these toxic chemicals so potent as a pollution is a concept called bioaccumulation or biological amplification. So initially what you might have is you might have these pollutants entering into the ocean, entering into a marine ecosystem, and they might be in relatively low levels. Something that, as we in humans, if we drank a little bit of the water, it wouldn't matter. What happens though is we think of it as energy moves up the food chain. We talked about this in the transfer of energy up along food pyramids or trophic pyramids. As we see energy being moved up the food web, we also see that these toxic chemicals are moving up as well. So if you look at this example here, and this is an example of PCBs. PCBs are an endocrine disrupting compound, disrupts the hormonal balance of animals, can cause reproductive problems, it can cause immunodeficiencies in marine mammals. Really nasty thing is, let's say some enter the ocean and phytoplankton absorb them. Not a big deal, but then zooplankton come and eat the phytoplankton. Then herring, for example, in this, as we see in this example here, come and eat the phytoplankton. And as you move up the food chain, you see that the toxic substance becomes increasingly concentrated until finally you get to large mammals or even humans. And we see that we have a huge accumulation of these toxic chemicals. They're stored in fat cells. They don't break down easily. So the end result is we see that quite often seafood through this can be unfit for human consumption. We eat the seafood and we're actually ingesting a lot of PCBs. Not what initially entered the ocean, but we're looking at the net effect of many, many, many particles of PCBs or other toxic chemicals entering the ocean. So this bioaccumulation, this bioamplification can cause serious effects, maybe not for the sort of the base of the food chain, even though this is bad for them, but as you move up, another term is biomagnification, the effects that they have increase as the amounts in bodies of marine organisms increase. Heavy metals can also act as a pollutant. Once again, small quantities of heavy metals can cause damage to organisms. And it's a case we also see bioaccumulation. We see this magnification. Small organisms, in this case here, we see krill. They get mercury in their body. Maybe not a huge deal, but then salmon eat the krill, trout or tuna eat the salmon, sharks, pikes, albacore, tuna, halibut eat the other fish. And we see that over time, as we move up and up the food chain, mercury levels increase within the organism. And mercury is bad. It interferes with our normal cell metabolism. It has serious repercussions for our nervous system. And you'll often find that pregnant women are advised to only eat tuna maybe once or twice a week or once or twice a month. That it's not a good idea to eat tuna every single day. And that's due to the fact that we have this bioaccumulation of methyl mercury inside the bodies of tuna. Other heavy metals can include lead. Lead can be introduced in the system through the mining process. This is something that we see in the picture there, right there. Sort of toxic heavy metal runoff from a mining operation. And even stuff like copper and tin can accumulate bioaccumulate, and cause potential problems for species further up the food chain. Another potential pollutant that can end up in the marine ecosystem are pharmaceuticals. And this is something that we've seen concentrations of pharmaceuticals increase in the oceans over time. There's a big public awareness campaign. If you have medicine that is unused, don't flush it down the toilet, don't pour it down your sink, bring it back to your pharmacist to deal with. Because what quite often happens is you take these pharmaceuticals, you take these pills, maybe penicillin for an infection you have, you don't use it all, you pour it down the sink. Eventually that penicillin is going to make its way into the ocean environment. And when it does there, it can have huge effects on organisms and the survival. So there's a lot of concerns now looking at organisms and how pharmaceuticals that are dumped into the oceans can affect them. We have oil entering the ocean environment as a pollutant. We have heavy metals, toxic chemicals entering the ocean environment, but we also have just plain old what we can consider garbage. A lot of material is either thrown on purpose into the ocean or by, a cup accident gets left somewhere on a beach, inadvertently makes its way into the ocean. Some of these things can just decompose rather quickly, but other items will take a long time to decompose. And in this graphic here, you see an example of some common items that could potentially end up in the ocean and how long it takes for them to decompose. An apple core, 2 months. I think we can live with that. It's an apple. It's fairly healthy. Little fish might be able to nibble on it. But then you look at something like a fishing line. Lots of fishing line in the ocean because people go out there to fish. Styrofoam cups, plastic beverage holders, disposable diapers. All of these take hundreds of years to decompose. And glass bottles, we don't know. We still find glass bottles from, 2,000 years ago in the ocean itself. So it takes a long time for debris to leave the ocean. That's why there's a big push on as well as you don't pollute in the ocean. Get rid of your garbage in a responsible way or get rid of your recyclables in a responsible way. The other thing that we see is sewage will enter the ocean. We really haven't talked about this at all, but many places with big cities or towns along oceans will have their sewage actually being released into the ocean. And there's a big movement as well to either clean up the sewage that's entering the ocean or not put it in the ocean as well. Another type of pollutant are plastics. And plastics in the oceans is a topic that's getting more and more airplay here in 2019. You turn on the news, you look on the web, you listen to the radio, if you still listen to the radio, and you'll find there's constantly stories about plastic in the ocean, how plastic's being introduced in the ocean, the negative effects that plastic can have, and what plastic can bring. We find that plastics might be affecting the ability for oxygen-making bacteria to live, and hey, we all need oxygen. So we see that plastic pollution is becoming increasingly a topic that more and more people are being concerned about. And it is an area that we should definitely be concerned. We look at the Mariana Trench, one of the deepest parts of the ocean, and when Vescovo, one of the people that traveled to the bottom of the Challenger Deep, went down there in May of 2019, he found a plastic bag. So even in the deepest part of the ocean, one of the most inaccessible parts of the ocean, we're finding evidence of plastic pollution. And this is pollution that's not going to disappear overnight, but this is plastic pollution that can persist for hundreds of years in the environment. Most plastics, but not all, are not biodegradable. We are seeing more and more biodegradable plastics being produced. And the thing is once they enter the ocean, either small little microbeads, as straws, as plastic bags, as food wrappers, as plastic bottles, they're going to accumulate in the ocean. And not only do they accumulate in the ocean, it's just the fact that we have lots of plastic in the ocean, but they also attract other toxic substances. We see that things like oily residue from oil spills, these nasty PCBs and dioxins, they're basically going to stick onto the plastics. So now we not only have plastics, but we have all these other nasty things associated with the plastics. Plastics will either float or sink, and when we look at plastic floating in the ocean, we're only seeing basically, for lack of a better term, a tip of the iceberg. It's estimated that about 70% of all plastics in the ocean will sink. So the problem is much greater below the surface than even at the surface. What can happen? Fish can ingest it. We'll look at sea turtles in a couple of minutes. Organisms become entangled in it. We have a picture here of a whale becoming entangled in a net. And once again, the sources are many. pollution, garbage being thrown into the ocean, fishing boats losing fishing gear, and it goes on and on the list of ways that plastic material can enter into the ocean. Yet another graphic that illustrates how long plastic can remain in the ocean. So it's believed that plastic bags, I might have been a little over exaggerating earlier, take about 20 years to break down. But then there are things like plastic bottles. You go and get a bottle of water or something. That's going to take about 450 years to break down. So some plastics can have a very long life within the ocean. I'm not going to say much about this slide. I think this slide speaks for itself, but you can see the effects of plastics on marine organisms. So with plastics in the ocean, we can have, from an aesthetic viewpoint, who wants to go to a beach that's filled with garbage, with plastic garbage? We know that plastics in the ocean persist for a long period of time, and that toxic chemicals, heavy metals, other chemicals in the ocean can be attracted to them. So not only do you get that plastic, but you get sort of this toxicity associated with the plastic pollution. The other thing is a lot of marine organisms will mistake the plastics for food, or they'll inadvertently eat the plastics. What happens is, if you have something plastic in your body's not going to absorb it, it's not going to break down, you're not going to derive any energy from it. You get enough plastics in your stomach, and we see this in the lower right hand corner of the image. This is all the plastic contents from a bird's stomach, a seabird's stomach. You never feel full. You feel full all the time, so you never go out and eat. And eventually, even though you feel full, you starve to death. One area concern with plastic bags is that sea turtles often mistake plastic bags for jellies. Sea turtles love to eat jellies. It's one of their main sources of food. We see that even after ingesting just one piece of plastic, an organism's chances of dying increases by 20%. So we have organisms eating food or eating plastic as a form of food. It increases their likelihood of dying. Just not a very good situation at all. Another area of concern in terms of plastics in the ocean, this is something we talked about, or I mentioned very briefly in a previous slide, are ghost nets. So these are lost nets, abandoned or discarded fishing nets or other gear. Basically, they sit there, they drift along with the ocean currents. Quite often, these nets now are made up of a plastic fiber, and they're going to last for decades to years, sometimes up to 500 to 600 years. They can travel long distances, and what they do is essentially what is termed ghost fishing. They're floating there, animals. Here we see a seal. There's a whale. There's a shark in this other image. They become entangled in the nets. They can't escape. They become exhausted. They can suffocate if you're an organism that needs to swim all the time in order to breathe. They can starve. We might even see amputations of limbs. So this is a real problem, and a real push is being made now to clean up the world's oceans of these ghost nets that just sort of float around and have the potential, this really great potential to do tremendous harm to a lot of different marine organisms. The other thing too is we can see fish being caught in these nets, and then they act as bait, and they're going to attract larger predators, which things such as turtles, sharks, dolphins, whales, which in turn then they themselves can become entangled in these nets. So it's a problem for small fish as well as larger organisms alike. And finally, plastic pollution just looks ugly. Here's a beach. Almost everything you see on here are plastics, and you can see it's just not a pleasant place to be. This can have a tremendous effect on the tourism industry, especially if you're a coastal community that depends highly on tourism. Nobody is really going to come and visit a beach that looks like this. So not only do we have the effects to the environment, but we can also have economic effects as a result of plastic pollution. Attention also surrounds plastics in sort of the open parts of the ocean. And we hear things about sort of the Great Pacific Garbage Patch, the trash vortex, the Eastern Garbage Patch. And we see actually throughout the world's oceans that there are basically 5 garbage islands. And referring to them as islands is kind of a misnomer. They're not actually this physical structure that you can go and step on, but basically it's an area of the oceans where, due to the way that water circulates in these ocean gyres, we see that garbage or plastic garbage becomes concentrated, and these can extend for thousands of kilometers. So we see here in this image is the Pacific Ocean. We have the Kuroshio current operating. We have the California current operating. So both are eastern and western boundary currents. And we see that we have water, the circulation of water results in the formation of 2 of these garbage patches. with materials sort of being floated or moving towards the center of the patch. The presence of these garbage patches were first described back in 1988. And it was actually by a racing boat captain by the name of Charles Moore who discovered one of the vortexes in the Pacific. He was sailing from Hawaii to California after competing in a yachting race. And as he crossed through the North Pacific subtropical gyre, what he noticed, he and his crew, that there were millions and millions of pieces of plastic surrounding the ship. So he got back to shore and said, hey, there's this potential problem within the ocean. Since then, scientists, environmentalists, researchers have been studying these garbage patches. They're unsure of the depth. They know they extend at least several meters in depth to possibly even hundreds of meters in depth. So not only do they spread laterally, but they spread vertically as well. We find that they're dominated mostly by microplastics. In this image here, we can clearly see some of the plastic garbage, but these little microplastics, these little sometimes tiny beads that are added in stuff like face exfoliants, that makes up the majority of the plastic material within the ocean. Of this, approximately 70% of the debris will sink to the ocean floor and have a negative effect on the benthic communities that exist there. Microplastics are plastics that are less than 5 millimeters in size, so they're basically microscopic. We really can't see them. And they consist of microfibers and microbeads. So fibers would be a little bit more elongated. Microbeads would be exactly what they think you are. They enter the marine ecosystem via many sources. As I said, some cosmetic products contain microbeads. So you use that cosmetic product, you wash your face, it goes down the drain, and any microbeads will enter into your ocean system or into your marine ecosystem. You can also have larger pieces of plastic, for example, plastic bottles. These eventually do break down into smaller and smaller pieces, and these will create microplastics as well. So we have microplastics that initially start off as microplastics, microbeads, and then we have microplastics that are formed by the degradation of larger plastic products. Both of these, whether it's initially starting off as a microplastic or became a microplastic, they persist in the environment at high levels, microscopic, so it's really difficult for us to see, but they're really dominant within marine ecosystems. And once again, a subject of great concern. In fact, the use of microplastics within cosmetic products and other sorts of products is being strongly discouraged, as once it was recognized that these things were accumulating within the environment. Once again, one of the concerns around the persistence of microplastics and just how much microplastics are present in the ocean is in terms of animals and nutrition. So you imagine an animal like a whale shark, and a whale shark takes huge amounts of water in its mouth and basically filters out all the plankton as something to eat. Now, if you look at these slide images here, these are images of plankton with plastic actually present as well. The plastic pieces are outlined in orange, and you can see that it's very difficult for organisms, especially a whale who's just taking a big mouthful of water, to make the distinction between plastic and if it's real plankton. So inadvertently, many organisms will ingest these plastics. Once again, they persist in their stomach, they make that organism feel full, and eventually the potential exists for these organisms to starve to death. Now, there is hope. It's recognized that plastics in the ocean is a major problem in terms of the environment and in terms of the health of the planet. So major efforts are now being made by countries, by corporations, by individual citizens to clean up the coastlines and clean up the oceans. One of the things we use is trash skimmer boats. These little boats sail usually in the near shore environment. They putt around and basically skim garbage off the surface of the ocean. We have more intensive cleanups going. One thing to look at is look at the website, theoceancleanup.com, where we go out and actively clean up parts of the ocean. We'll see what's happening here in the next slide. This graphic shows one of the methods that's used in the ocean cleanup to rid the ocean of plastics. Basically what happens is you have two ships. The two ships pull a huge line between them, and underneath this line is the screen. They eventually move closer and closer. What happens is it brings forces the garbage, the plastic, all sort of into one central location. And then another vessel comes in, it acts as a garbage truck, and it removes all the collected garbage off the top of these sort of enclosed locations. So I think I said two ships earlier. It's more like two stationary structures in the ocean that sit there and float and collect the ocean, or collect the garbage, and all the garbage moves into the middle of that sort of semicircle black pipe or black tube that we see in the ocean. Picks up the garbage, removes it, brings it off back to shore, where then it is dealt with, either recycled or in some sort of manner to make sure that it doesn't re-enter into the ocean environment. There are also some simple and low-tech ways to ensure that plastic and the garbage of all sorts doesn't make it into the ocean. Here we have, this is at a location in Australia, sewers or storm sewers that enter into the ocean at one point. You put these big nets at the end of them. The water will make it through, but all of the debris of a certain size will be caught by these nets. The other thing is simply don't use as much plastic, or be very careful and aware of where you put your plastic, that it isn't going to make its way inadvertently into the ocean.